Today's lesson is on recursive sequences. What type of sequence is 5, -1, -7? Notice the terms and see if you can figure out, is it an arithmetic or a geometric sequence? If you say arithmetic, you are right. Because you are adding a -6 each time. Number 2 says write an explicit formula for the sequence. So that would be a sub n equals, it starts with 5, and then because you're adding a -6, you can put -6 to the n minus 1. Number 3, what type of sequence is 4, 6, and 9? This one would be a geometric sequence. Figure out what you are multiplying by each time to get from 4 to 6 and from 6 to 9. Remember, you can write this as a ratio of 6/4 and simplify that to 3/2. So when we have to write an explicit formula for the sequence, we are going to write a sub n equals, the first term is 4 times 3/2 for our common ratio to the n minus 1. Number 5, a young pair of rabbits, one of each sex, is placed on an island. A pair of rabbits does not breed until they are 2 months old. After they are 2 months old, each pair of rabbits produces another pair each month. If no rabbits leap or die, how many pairs of rabbits are there after n months? Okay, so part A says, what type of sequence is this? So you want to take a look at the values you're getting here. You're going from 1 to 1 to 2 to 3 to 5 to 8. So what kind of a sequence do you think this would be? If you are saying that it is not geometric and it is not arithmetic, then you would be correct. Part B, is the information discrete or continuous? What do you think? If you say discrete, you are correct. Part C says, how many pairs would be on the island for month 7? So let's go back here and let's look. Here's month 6. So you want to figure out, how am I getting each of these terms? Notice that 1 plus 1 is 2. 1 plus 2 would be 3, the next term. 2 plus 3 is 5, which is the next term. 3 plus 5 is 8. And so you're actually adding the current term with the previous term to get the next one. So if that were the case, then 5 plus 8 would be 13. So to write the sequence would be 1, 1, 2, 3, 5, 8, 13, and it would keep going. Leonardo Fibonacci, who was born in the 12th century, studied a sequence of numbers with a different type of rule for determining the next number in a sequence. Leonardo Fibonacci came up with the sequence when calculating the ideal expansion pairs of rabbits over the course of 1 year. The famous Fibonacci sequence has captivated mathematicians, artists, designers, and scientists for centuries. The sequence has been found in many things, from the number of petals on flowers to the paintings of Leonardo da Vinci. This sequence is neither arithmetic nor geometric. Each term is found by adding the previous 2 terms. This is known as a recursive sequence. Recurring meaning occurring again and again. A recursive sequence always uses the preceding term to find the next term of the sequence. Number 6. Could the sequence 5, -1, -7 be called a recursive sequence? And if so, what do you do to the previous term to get the next term? Yes, it can be called a recursive sequence. You would subtract 6 from the previous term. Number 7. Could the sequence 4, 6, 9 be called a recursive sequence? If so, what do you do to the previous term to get the next term? Yes, you would multiply by 3/2. Most sequences are recursive and can be written using a recursive formula. Since recursive sequences are found by using the previous term, the recursive formula has to have 2 parts. It's very important that you know, and I would box that in, that there are 2 parts. A sub 1 is representing the first term, and then the second part here, this is representing the previous term. So, and the previous term, and also showing if you're going to add, subtract, multiply, divide, or whatever operation will get you to the next term. So let's take a look at this one right here. The sequence 5, -1, -7 can be written as a sub 1 equals 5, that's the first term, and a sub n equals -6, because that's what you're doing, plus the previous term, which we write as a to the n minus 1. Here's another example, 4, 6, and 9, a sub 1, meaning your first term is 4, and then a sub n equals 3/2 times whatever your previous term would be. All arithmetic sequences and geometric sequences can be written using an explicit formula and a recursive formula. Number 8, write an explicit formula and a recursive formula for the following numbers. The explicit formula would look like this. You would have a sub n equals 80, because that's your first term, times what is happening here. Well, if you take the 32 over 80 and simplify it down, it will simplify to 2/5. So you have the common ratio of 2/5 to the n minus 1. The recursive formula would look like this. A sub 1 equals 80, meaning that's your first term, and then a sub n equals, and 2/5 is what you're multiplying by, times a to the n minus 1. Number 9, write an explicit formula and a recursive formula for 23, 31, 39, 47. Okay, well, an explicit formula would be a sub n equals, and then look at what you're doing here, from 23 to 31, you're adding 8, but notice that you start with 23, so you want to write 23 plus 8 to the n minus 1. And the recursive formula, a sub 1, meaning your first term, which is 23, and a sub n, you're adding 8 plus a to the n minus 1 is your previous term. Okay, on number 10, what is the domain for each sequence? Your domain, your x value, is going to start with 1. Remember, we discussed that. And then it's going to go 2, 3, 4, 5, 6, because this is representing your term numbers. So it's going to be positive integers. Okay? The table gives the number of people that get a text message. Each person has to forward the text to 3 other people. Write a recursive definition for the sequence. Okay, well, notice that it starts with 1. So remember, we have to have 2 parts here. So a sub 1 is going to be 1 for our first term. And then a sub n is going to be, oops, hold on, let me see here just a minute. There we go. Okay, a sub n is going to be, see, what are you doing here each time? You're multiplying by 3. So it's going to be 3 times whatever the previous term was, because you have to, so 1 times 3 is 3, then you take that 3 and you multiply by 3 to get 9. Okay, so that's your recursive definition. The domain, what is the domain? Well, if you look here, it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Part C, would it make sense for the domain to go to infinity? What do you think? The answer in this situation would be no. Eventually, everyone in the world would get the text. Okay, that is the end of the lesson.